In this video session, I'm going to show you step by step how to use YOLO v4 to do object detection in any video clips. Let's start. So actually, I'm going to using the Google Cloud Platform Vertex AI Workbench. So that is previously named as AI Platform Cloud Notebook. So just renamed recently by the Google as the Vertex AI Workbench. So let's spin up some virtual instance, and then you actually can open your notebook, and then you can just open the notebook instance and create or upload some existing notebook to start your study here. So already I created a notebook YOLO v4 object detection. So in summary, YOLO v4 improves both speed and accuracy on top of YOLO v3. Also, it supports both hardware CPU and GPU. Here also I give a bit like more information as background information for better understanding of the YOLO v4, v3, and also the difference between the one stage and the two stage object detection algorithm. So why are we using YOLO? Because YOLO is fast, accurate, and open source, and also it's free. And also, we are going to install the YOLO in the first place. So here is the step. You have to check the GPU information and then install the darknet. Darknet is actually written in the C. It's the open source neural network framework acting as the backbone for the YOLO model. So then we can also download the YOLO v4 OS for the model neural networks, also enable the GPU and the OpenCV options, then make the package and then ready to use. Okay, so this is actually showing the GPU info. Here you can see for my GCP virtual instance, so I'm using some Tesla T4 GPU. Then this cell actually do the actual darknet and all the dependency installation work. So you only need to execute this cell once at the beginning of your notebook work. So once done, you can just disable it, because I already installed it and I just deactivate it. So when you actually return to rerun the script, just starting from here, okay. So we actually just first input all the dependency, like the OpenCV libraries and all the datetime for the calculations, prediction delays and the NumPy and so on. Okay, so actually I put my object detection experiment notebook in this subfolder, but you can actually create any subfolder for your experiment. Next, I define some utility functions. So these utility functions actually calculate any video's FPS frame per second. That is the video's frame rate, and also the total number of the frames in the video clip. So it depends on your OpenCV versions. There is different command to do the corresponding calculations. And then another utility functions. So this utility function is actually to do the three tasks. So firstly, I will check if the input video is the MP4 format. If it's not, I will convert it and into the MP4 format. And in the second step, also I'm going to reduce the video's FPS if it's exceeding a predefined threshold. Okay. For example, if your object detection algorithm can support a maximum of 30 FPS. So if the video clip you are going to use for detection is actually the FPS is more than 30 FPS, so you have to reduce it. So this is some like a proper command, you can do it. And then in the third step, I'm going to actually resize the video to make it suitable for the visualizations in this notebook. Okay, so this is actually the well-defined functions for the input and output. Okay, so let's actually move down and so actually let's actually to give us some random video sample for testing purpose. Okay. Okay, you can see here. So I just like using some like airport samples here, and you know, the output for my utility functions tells me this video clips is about like the 53 seconds long, and it contains about 1,600 frames, and also its FPS frame rate is about 30. Okay. So this is actually, I just visualize this video CV. Let's actually to make this window is a bit bigger. Okay, so we can just like to click on the right. You can, this is actually the airport, a lot of the moving airplanes, trucks, and even some person. Okay, so we are going to using this sample video to test the YOLO V4. Okay, so in the next step, we are going to actually define our another utility function and to apply the YOLO V4 to infer the any objects classes and in the video images. Okay, so this is an actual function to the job, and I wrap it into some utility function. So also I calculate the how long it takes to actually to detection the objects in the whole video, and all the result will be output for the further analysis. Okay, so you can see here, and from when I call these kind of functions, and I can know this video frames is contain 1,600, and for the YOLO V4 predictions, the whole processing time is about 57 seconds, and the inference time per image frame is about 36 milliseconds. So roughly you can see like it can support roughly 30 FPS, so near real-time detections for the YOLO V4. Not so bad. Okay, so before I visualize the prediction results, and I have to actually to convert the the output video, which is actually the using the video codec or MP4, and I have to convert it back to the H.264 codec in order for the notebook to actually visualize it. So this is just a single line of the command to do this job. Okay, so then I visualize the detection output video after the processing. So you can see the detection. Okay, so let's actually do okay, you can see this is the detections. The YOLO V4 detects all the things, trucks, moving airplanes, which is partially overlapping each other, and also detecting the trucks and the cars, and can even detect some person sitting inside the car. It's not so bad. Okay, so it's quite accurate. Okay, you can just like running this video detection output to observe the result and to detect if any misdetections and any false positive and the false negative. Okay, right. Okay, here is some tip. The video detection speed, that is the prediction latency, is actually decided by two factors. It's decided by both the object detection algorithm. So what type of algorithm you're using, if you're using the real-time detectors or you're using the non-real-time detectors, and also the hardware. Yeah, if you are using the GPU or you're using just the CPU. So that makes a big difference. So these two factors actually in turn decide the maximum FPS support. Okay, so for example, if a given algorithm running a given hardware, the can achieve the per frame detection latency about 20 milliseconds. It means it can process 50 frames per second. So it can support a maximum of 50 FPS. Yeah. So this is the calculation. So in the next step, we are also going to test another lightweighted version of the YOLO V4, which is called the tiny YOLO V4. Okay. So this tiny YOLO V4 can work at the much higher frame rate, so up to like 155 FPS, but it depends on what actual the hardware GPU variations they are using. But they actually with a little bit less accuracy compared with the basic YOLO V4 model. So here this is another utility function to actually using the YOLO V4 tiny to actually do the object detection. So just this one line code, and also we are going to calculate how long it takes for the YOLO V4 tiny to detect the whole video clips. So this is output. Okay, so once we actually to see this one, and then just call these utility functions to make the actual detections. Here you can see, once this detection is running, all the neural network layers can be visualized in the output, and also for each video image frame, it can show you how many and which object classes has been detected, and also the object class detection confidence score. Okay, so this is like all the information has been visualized frame by frame. So this is a lot of the frames in our video clips, like 1600, right? So I just don't need to go through all them, and let's say to make this result is shrink it, and then we can move to the next cell. Okay, you can see the video frame 1600, total number of the video frames, and the total processing time for tiny YOLO V4 is just 10 seconds. It's much faster. The recall we used to have like 57 seconds, right, from YOLO V4. And also the inference time per frame is only about 6 milliseconds. It's much faster, about almost like 6 times faster compared with the 33 milliseconds per frame detection from the YOLO V4. Okay, and this is our YOLO V4 detection latency per frame. So this is our tiny YOLO V4 detection speed is 6 times faster. Okay, so you can see it says much faster, and also can achieve like the maximum about 144 FPS support on our GCP platform with the T4 GPU instance for a quick test. So next, let's actually to take a look at the actual result. So this is the tiny YOLO V4's result. If I click the run button, you can see that it also makes a lot of the detections. But however, you may notice its detection accuracy is a bit worse than the YOLO V4. First of all, a lot of objects haven't been detected by the tiny YOLO V4. For example, this person sitting in the car was previously detected by the YOLO V4, but cannot be detected by the tiny YOLO V4. So there is always some like a trade-off between the latency and the accuracy. And for the object detection algorithm, we always emphasize. So this is some engineering trade-off you need to be aware when you try to select and apply the YOLO, the detection models to your actual project and use case. Okay, let's actually to move to the next cell. So we can also like try another video samples. Here I just get another video samples, and for this video samples, you can see it only contains 435 frames, and it's only like about 14.5 seconds long. So it also has the similar FPS rate, about 30 FPS. Okay, and this is the second sample video. So this is show like the people with the handbag and luggages, working in the lounge, and also some like TV monitors and so on. So it's another sample we're going to test. So again, we just like call this YOLO v4 object detection utility function we defined before, and it's actually starting running, and you can see all the deep neural networks layers has been visualized, and then frame by frame is just indicate us how many objects and what object class has been detected with the confidence score and with confidence score. Okay, so many okay, right. So let's actually to minimize this output window. Okay, and then we can take a look at the actual outputs. So here you can see, this is actually detected by the YOLO v4 and take about 20 seconds for 14 seconds long the video clips, and the inference time per image frame is about 47 milliseconds on our T4 GPU instance. Okay, and okay, so this is actually shows the results, and let me try to adjust the window. So if we click on it, you can see the people's, the handbags, suitcase, multiple instances of people, and also the clock, and has been TV monitors has been nicely detected by the YOLO v4. Okay, nice. Okay, you can just like play around and you can enjoy watching all day long for this. Okay, right. Let's move to our tentative conclusion, right? So we can see like the YOLO v4 is an improvement of the YOLO v3 in terms of both speed and accuracy. So actually, we also did another hands-on experiment demonstrating how to using the YOLO v3 to actually detect objects in the images video, and just refer to my another tutorial video clip. And so according to my test, if I run in the YOLO v3 on my MacBook, so with only CPU without any GPU, so it take about like the 300 milliseconds, sometimes even like 600 or 800 milliseconds to detect the objects in the each image frame. While if I test the same thing on the GPU instance, it can just take like 170 milliseconds, about roughly 2 times faster. So also I using the YOLO v4 on the GCP GPU T4 instance. It's only take about 30 milliseconds, about 10 times faster than the YOLO v3. So also the YOLO v4 is able to detect smaller objects like the backpack, which could be the various advantages against the v3. Tiny YOLO v4 is even faster and lightweighted, so it can support like the more than 150 FPS on our Google Cloud Platform instance with 1T4 GPU. Typical video FPS range from 30 to 1000. So if a raw video has a very high FPS, so we can reduce the bit by filtering out its FPS to make it suitable for real-time detection. So basically, it's a trade-off between the detection speed and the granularity. So virtually, we just need to sample some frames to detect rather than detect every single frame. Okay. So also YOLO models generally perform well out of box for the 80 object classes in the Coco dataset that it was trained upon. However, for those specific objects classes that the YOLO haven't yet been trained on, so just like some router box or some any new objects, it actually cannot detect such kind of new object class. So in this case, transfer learning is required to fine-tuning the model and to pick up the new capability. Okay, so there's also some reference I indicate here for you to explore the YOLO model that is trained in the people detection and counting, and also look at the potential use case of the real-time detections. Here is some database, it's some like the trial version of the YOLO v5. So we also can explore with some dataset, indicated here. Okay. Today, step by step, I have walked you through how to use YOLO v4 to detect video objects in an easy way. Give it a like if you found my tutorial is useful to you, and subscribe to my channel if you'd like to download the whole notebook code for your study and reproducible research. See you soon later in the next session.